All right, welcome to 2.6. This is an introduction into factor fixing. We're going to start talking about factors. I'm going to try and get through this as quickly as possible, and I'm going to kind of jam through it. You're going to have to pause because you're going to have some diagrams you're going to have to write. The very first question that it talks about, it goes through and it reads, in fact, I encourage you to pause and read the paragraph and then come back. And if you've done that, question number one says, can you find a different expression to represent the area of this new rectangular block? Well, up until now, we've been talking about things that are perfect squares. We've done the same thing to one side as we have to the other. In this case, they're saying, well, gee, I'm adding 5 to one side, but 2 to the other. So if I don't add the same thing to both sides, what happens? Well, go back. It says, can you find a different expression to represent the area of this new rectangular block? It should be sensible. If I do 5 to one side, if I expand 5 on one side and only 2 on the other, the shape that is created when I draw it out actually ends up being a rectangle. And that's what they want us to do with this first question. So I'm going to expand each side. One side by 5. So there's 5 on one side and 2 on the other. Okay, so if I've done that, now I want to write 2 expressions to map this area. Well, I have 1x squared. I have 5, 6, 7. I have 7 x's. And I have 2, 4, 6, 8, 10. I have 10 single unit squares. Another way to write this is simply writing it out as a product of factors like they have, or I could write it out in an expanded sense, which if we multiply, we get x squared plus 5x plus 2x plus 10. And notice that these are like terms. Okay, so it's having us draw a diagram for that. Question number 2, since we are drawing diagrams, it says the original square block was extended 3 inches on one side and 4 inches on the other. So think about what that looks like. 3 on one, 4 on the other. I'm starting with this original block. Pause and see if you can create that model. If you paused, this is the model you should have created. 3 on one side, so x plus 3, 4 on the other, x plus 4. Now I want to write it in 2 forms rather. Well, gee, x plus 3, I'm writing it as a product, x plus 4, there's my product. Now I'm going to write it as a condensed form. 1x squared, 4, 3 is 7 x's, 3, 6, 9, 12, plus 12 single unit squares. Question number 3 says the original square block was extended 4 inches on one side. 4 on 1. All right, so again, pause and see if you can do that. 4 on one side. Think about what that's going to look like. Okay? Let me double check and make sure I'm in view here. Yep, I am. So 4 on one side. Again, pause it. All right, so if you come back, this is what your diagram should look like. It said 4 only on one side. So show it as a product. The area is equal to length, x, times width, x plus 4. That's one way. What's the other way? Well, I have 1x squared, and I only have 4 x's. So there you go. Question 4 says the original square block was extended 5 inches on one side. And, 5 inches on each side. Okay, so 5 on each. There was a little bit of miscommunication in classes where they thought that we expanded 5 on all 4 sides. No. Did we ever do a diagram like that? No. We've never done that. So what it means is, it means 5 on one side, and it simply means 5 on the other. That's what it means. Okay? So 5 on one side, 5 on the other. If I do that, I get x plus 5, x plus 5. I'm going to write it as a product, which is x plus 5 squared. Why? Why can I do that? Because I did the same thing on both sides, which is what we're used to seeing. I'm also going to write it as a product, x plus 5 times x plus 5, just not as using not using an exponent. And x squared plus 5x is 10x plus 25 single boxes. Okay? And then 5. You should be getting the picture. 5 says 2 on 1. Why do I always want to say 2, 1, 1? 2 on 1 and 6 on the other. Pause it and try and draw that. Okay? Again, it should be 6 on 1. Two on the other. X plus 6, x plus 2. X squared plus 8x's, 6 on one, 2 on the other, plus 12 single units. All right? So there is part A, and I will continue next with part B.